Alrighty, so I'm Alex, and I'm here mostly to talk about hybrid apps with a little bit of Ember content. Just so I can be on point with everybody, who here actually knows Ember, has written an Ember app before? Okay, sweet. So I'm basically going to do a very quick crash into Ember for like 2 minutes, but we'll mostly talk about hybrid apps and how they work instead. So in terms of what we're going to talk about today, a little bit of a preamble. We'll go into the Cordova and Ember ecosystem, just what are both of these tools if you're not familiar, just in general, how do they work and how do they work together. Then I'll introduce you to ember-cordova, and we'll just go through how we build these apps, how we make them feel performant, and some tips to make them feel completely native. Before I get into that, so I'm actually one of the other partners at Isle of Code. We're a Toronto-based consulting company, effectively, that specializes in Ember and doing a lot of hybrid work. So you heard Aiden talk about Electron. I tend to focus more on mobile and stuff like that. Also, I actually maintain ember-cordova. That's probably important to point out. So for those who have never used Ember before, Aiden covered some of this. It's basically content theft, and I will report it. But Ember is a framework for ambitious applications. So whereas a lot of other JS frameworks you hear are really better? Whereas a lot of frameworks that you use are really designed to do small component pieces, Ember is too much? Is really designed to build a large app and to help maintain everything that's going on. So your CLI is first class, our router is first class, our controls and components are first class. Our actual way of interacting with an API and pulling in data is first class and standardized as well. And this becomes really nice as you're starting to go across 7, 8, 9 different Ember apps, and you can basically trust that they're all structured exactly the same way. And an Ember developer is generally interchangeable on every other Ember project you're dealing with, which is really nice in JavaScript because I don't think that exists in a lot of other places. So another quick show of hands, who here has actually built a Cordova app before? Okay, very few. So if you don't know what Cordova does at a very high level, if you've heard the word PhoneGap thrown around, for the purpose of this talk, it's basically the same thing. I'll distinguish them later. Is Cordova lets you build a native Android app, native iOS app, native Windows app that is basically a full screen web view. So then we can go and run our SBA or our JavaScript application inside of a native shell and trick the user into thinking we have a native app. Performance is sometimes a problem. Once you know what you're doing, that's not the case, and we'll talk through how we get there as well. And the real reasons you want to do this is, one, you can start to get that sweet App Store distribution. But there are a lot of things that mobile web still cannot do, right? Like we can't register to send push. There are a lot of system level APIs that we can't get access to. So Cordova starts to really make sense in these contexts. So just if you've never seen the system before, this is not an architecture graph, but it's just, we'll give you a high level introduction. So most people who interact with Cordova would just download the CLI, which implements this library called Cordova lib, which you can imagine is where most of the primitives that a user would use are. It's where a build is, where a run is, and I'll go through and show you what those do. We then have our standard application code. In my case, that's usually Ember. Sometimes it might be a React or something like that instead. And then in Cordova, we have different platforms, which is what we're distributing or building for, right? iOS, Android. And we have plugins, which is just pre-built system interactions. There's a camera plugin, for example. Simon over there works on the push plugin, loves getting issues opened and technical support requests on Twitter. So that's basically how Cordova works. And if you're kind of wondering what the difference is with this PhoneGap thing, the TLDR is that Cordova did used to be called PhoneGap. Now we'd usually use the Cordova word. It's fair to say that PhoneGap implements Cordova, but Cordova does not implement PhoneGap. PhoneGap is basically a layer on top that gives you some value-added stuff. In a lot of cases, I just use the Cordova CLI because I don't use those, but it's worth looking into the differences for your own use cases. So before I get into actual technical stuff, just why do we do it this way? Because it seems a little bit complicated to take a JavaScript app, try and make it performant enough so a user can't even tell it's a JavaScript app, and then compile it down to a native shell. So the reasons I do this are a fewfold. One is just because it's Ember, and I actually prefer writing Ember. I quite like using the framework. The other is cost, right? We are a dev shop, and a lot of times people need us to get things done within a certain range, and it's nice being able to take this one source of code and have it working in 2 different contexts. We actually have this other thing called Flexi inside of Ember as well, which lets us inside of Ember conditionally render a desktop or a mobile template. So this starts to get really fun because we truly are using one piece of Ember source for our desktop, our mobile sites, as well as our iOS and Android applications. Hiring is something that nobody talks about as well, but Especially in hybrid, I think this is important because if you're a smaller company or even if you're bigger, it's really hard just to find devs, and it's going to be very hard to find an iOS and an Android person if you're just not already in those communities. So if you're entering this space for the first time, at least knowing you can hire one developer who knows what they're doing might just get you a better proof of concept or out the door a little bit faster. And also just the last point I'll mention is speed of development. So that's not just that you can actually get an app out faster, as much as we've all had these experiences where you download an iOS app and the Android app has a completely different feature set, and we're waiting for these two things to get back in sync. And this just propagates through a company and problems become worse as now the PMs don't know what different apps are doing. We're promising different features to different users. It's nice just to completely sidestep all of those problems and know they're not a thing. So the last point I make before we get into some actual technical content here is that good code equals good hybrid. And I bring this up because a lot of people who have used Cordova or PhoneGap before have just gone and dumped in whatever it is they've been working on and have said it's slow, it's chunky, it doesn't feel native, and they've basically blamed the framework. I think this is on, and that's why I'm echoing. And that's actually not the case. In a lot of cases, what's gone on is on a desktop machine, you just haven't noticed that your app is not very performant because you're running on a slightly bigger machine. You're usually not as animation heavy as you once were. So you just don't notice. So we'll go through some profiling stuff as well. And what I work on is ember-cordova. So what this does is for Ember developers, it makes it easy for us to take the existing application we've written. A lot of the stuff I talk about, if you use React or Angular, the same will apply. You just can't use my toolkit for it yet. But it takes that app and handles compiling it and putting it into the actual iOS or Android shells for you. So you bypass using Cordova and you just stick within the Ember CLI that we're all used to. Before working on this project, this is actually what I used to do. We had a giant make file that would just go and run commands and copy things over, and it would basically break all the time. And that's where ember-cordova came in. So what it is the library for packaging those applications, as I said. What's included in there is a CLI, which I'll take you through, so we're actually able to handle your builds for you. We have a live reload that I'll show you as well that works on devices. And we're adding some other stuff that we just know every single Cordova dev needs to use. So icon and splash generation is first class to actually ember-cordova. And we have a lot of people in the community as well of ourselves who are actually writing plugins for this as well. So while there's a huge community of plugins for Cordova, when you start using those in a modern JavaScript app, they're maybe in a pattern that you don't work with anymore. They're all callback-based. At least in Ember, we tend to be a little bit more promise-based with how we deal with things. So basically going through and writing small add-ons on top of those existing plugins so people who want to interact that way can. What ember-cordova is not, because we get this all the time, is we're not a UI library at all. So this is one thing that is totally not like Ionic. We have no pre-built components. We will never give them to you. We have no interest in giving those to you. There are a lot of good frameworks inside of Ember. You're welcome to go and pick and choose those. That's not our interest. Frankly, I don't even find that very fun to write. We don't even have an opinion as to which one you should use, but if you go to the website, we certainly name 2 or 3 that we know are very performant. And we don't actually protect you from bad performance. So we're not trying to give you all of these bumper bars. You kind of do need to know what you're doing, but we certainly will warn you from the CLI if we know you're doing something that's wrong. We're just going to let you do it anyway, and we're going to let you blow everything up. It's pretty fun, live on the edge. So one other thing that we do is in Cordova by standard, unless this has changed since I last checked in the last month or 2, it default gives you a UI web view. And this is in iOS. There are 2 different web views that you can render in, a UI web view and a WK web view. The WK web view is newer and much more performant, but there are a couple of drawbacks in terms of things you can and can't access. For most Ember apps, this isn't a problem, so we actually just default to WK web view in Ember-cordova. There are different C flags you can use if you'd like to turn that off. And I bring this up as well because even if you're not using our tool chains and you're building a hybrid app, probably just start with WK until you're actually having problems, and then you can always downgrade because you want as much performance as you can get. So to show you what the install process looks like, I don't even try to live code anymore, by the way. I just take QuickTime videos of things working and play them for you all. I've done this for a bit. But to show you, so within Ember, we actually have add-ons that are first class to our CLI. So we just type in Ember install name of add-on and it will plug in. And that's exactly how Ember-cordova works, and it goes as far as pulling in Cordova for you as well. Actually, before we play this, The other thing to point out is that we're completely Yarn compatible as well. So you can use this with NPM, you can use this with Yarn. The install you're going to see is actually with Yarn, but I also did it on the train on the way here, so the Wi-Fi was not the best. So we just Ember install ember-cordova. We wait for the train Wi-Fi. You'll see in this case, we're installing with Yarn just because it's detected that I'm using Yarn. You don't have to do anything else. If Yarn's not installed on the machine, it will just default to using NPM. Waiting, this was the period where I was like hoping that I'd get in earlier last night and I could have done a better video. So the next thing it does is it goes through and just changes your Ember project. I'll show you what that looks like, but we're actually adding the Cordova directories inside of your Ember project. Then it's gone through and done the blueprint. And you'll see we have an ember-cordova directory there, and that's just being jammed straight inside of our Ember app for us. So as a user, you generally won't need to interact with this folder. You'll keep using our CLI, but it is there within your project as you need it. So the next question is, great, we have an existing app, so how do we get this in a container just to see that it's working? So that's pretty simple. We have one of our CLI commands is ember-cdv build, and this does a couple of things. The first thing it does is it goes through and makes sure our app is actually structured in a way that will work in Cordova. So while we don't protect you from bad performance, we'll warn you about things that we know the app just completely won't work. You're going to get a white screen of death. So there's a couple of things here worth pointing out because, again, even if you don't use Ember, this will matter. So the first thing you see it's warning us about is that our root or base URL has a leading slash. Same thing Aiden mentioned, again, content theft, but a leading / in any file-based system is generally unwise. So it's telling us we need to change that. It's also just telling us we need to change our location type to a hash for the same reason, because otherwise we're going to end up with a few too many slashes. And it's telling us that I don't have a platform installed. So I'm trying to run a build, but I'm not telling it whether I want to build for iOS or Android just yet. So we'll just go through and make those quick changes inside of our config. If you've never seen this before, this is just a standard part of Ember. We have a config environment.js. It does exactly what you think. It's where we store our config variables. We can customize them based on the environment we're dealing with. If a lot of this is feeling really similar to how a Rails app would work, it's because there is a lot of pedigree or heritage between how Ember runs and how Rails works. So a lot of people that I know who even write Ember, most of us came from Rails up until recently. So I've gone through and fixed that. Don't even have to code, it's great, I just stand here. Then we're going to run build again. It's going through, so the first thing it's doing is it's running our standard Ember build, which is part of the Ember CLI, which will go through and compile your Ember app for you into development or production. All of the same C flags that you'd use when you're interacting with Ember work. You'll see once it's finished that, we actually copy the assets to the place we need them, and it goes through the standard Cordova build process. I didn't even bother changing any of my debug outputs as I was building, so you're just going to see everything coming out here. If I'm not mistaken, when I was on the train, this build actually errored. I don't think I even edited out the clip, so we'll see if that happens. So you'll see that that build had gone through, it had gone through, and had finished building. So the next thing we do is we've got a compiled app. So what do I do from there? So we want to actually go and run that on our device. And there are two different ways that you can do that within an ember-cordova context. You can just pop open Xcode and flash it, which is what I'll show you, because I figured they're the tools that you already know the best. The other option that you have is to just use the CLI and do ember-cdv run. And that will just handle flashing it to whatever device you have plugged in, or it will boot an emulator for you in the exact same way Cordova run will work. It just won't make an attempt to do a build beforehand. So in this case, what I'm going to do is use a really cheap command I wrote. I'll show you the CLI in a second, called ember-cdv open, which just looks at your last build and pops open Xcode or open Android Studio for you, so you don't have to think about anything. Then you'll see I just went and ran for an iPhone 7 emulator, and I'm waiting for it to boot here. And I have just the standard Ember screen, right? So every Ember app, if you don't give it a default template, it just inits with this basic welcome page, so if you're new, you know what to do. So this is actually running in an iPhone 7 emulator. I could have flashed that to my device. It's just much harder to demo in front of a group of people. So the next thing we start to think about is great. So All we've achieved so far is we've taken our basic SPA and we've made it work inside of a shell, and we want to start making this feel like an actual app now. So the first thing we're going to start thinking about is splashes and icons and stuff like that, because every app has those. So in my case, you'll see I've already done it. I just made an icon that is a small red square. Let's go backwards again. So you'll see right now it just has the standard default Cordova icon, which is not what we want. So what I did is, with our standards, you'll see that there is a splash.svg. And the way we do icon or splash generation is you give us a single SVG file, which is called icon svg splash svg. If you go to the website, we actually have a grid that you can fit that in to make sure that nothing will get cut off. And we will intelligently look at what platforms do you have installed in your Cordova project, resize that SVG for every single one, and make sure that hits your Cordova config in the right way. That happens just with this ember-cdv make splashes or make icons command. If you've not dealt with Cordova before, it actually can be pretty annoying dealing with the icons, just because you have so many different varieties of sizes and shapes and your resolutions of platforms is different. This is also why we do SVG, because we can resize in a completely lossless way as we need to. So that process had finished, and what you can see here is it's gone through, and in my actual config, all of these splashes are done. And if we go through and there we go. And as you can see here, we have splash ID and icon ID in the actual config file. If you've never seen this before, this is config XML. This is basically Cordova's equivalent of a package JSON. If you're asking why that's not a package JSON, it's just that Cordova is very old. I wouldn't be surprised if package JSON wasn't even a standard convention at the time that was authored. It wasn't. There we go. I always tell people that in a lot of ways it actually predates NPM, and that's why it's structured like it is. You have a microphone.
Yeah. Oh, wow. Okay. But yes, we are moving to package.json for all of the things. So config XML is transitioning towards package.json. We're getting more modern. We're trying to catch up with all the hip, cool kids.
I remember the RFC, so I've been pretty excited. I still DM people there and just like, when is this coming? When is this coming? I want this. So I'll be happy about that. So just to show you as well, you can see now in Xcode that we have a little red dot next to our app. That's because I've actually gone through and have changed the icon, and that generation has been completed. And just to boot it up, because I also generated splashes as well, we'll pop over to our emulator. And I have my wonderful splash screen here, which is just a giant red box that then takes us back to the app. So that's all pretty simple so far, right? We haven't actually had to interact with anything native. We haven't had to do anything at all. And we have our standard JavaScript application working as a native iOS app. We managed to go through and actually get icons and splashes and all of this platform-specific stuff running with effectively 3 CLI commands so far. So before we go into more CLI commands, the next thing we're going to notice as we use our app is there are just some things that feel very webby. And if you've not done hybrid before, you realize that we almost have a different expectation of how things work. So one of the first ones is that we just have this different expectation in terms of how bindings will work. We expect them to actually work. If you're dealing with mobile Safari, you might find that your touch and click actions are detected a little bit strange depending on the framework you're dealing with. Inside of Ember, the sad hack is that we just have to put a cursor pointer on everything, and then Safari will recognize our clicks again. So if you're in this weird environment where you're tapping things and your framework is not realizing what's going on, I know this used to happen in Angular as well, just cursor pointer everything and you'll be fine. The user can't even tell it's a pointer because they can't see the cursor. The next thing we start to notice is, every link I've clicked is blue, and that doesn't happen on apps, right? That only happens on websites. So we're dealing with a website, we just need to go and restyle our CSS. That's not the case. Little line of CSS you can add here, and that's going to make sure that links we've clicked just look like normal text or how we've styled them, and we're not doing any retroactive, clicked link styling. Oop, I didn't mean to press escape there. So the next thing we start to think about is, great, I know I need to make some changes, and I don't want to keep going through that recompile process, right? You saw that was taking me 50 seconds to a minute even on the video. So one of the other things we have in ember-cordova, I'm sure other things support it as well, just in our case it's very Ember specific, is we have live reload working as well. So if you've not dealt with Ember before, ember-serve actually does live reload in your development flow, right? You type ember-serve, you go to localhost 4200, anytime you change CSS, install a plugin, change a template, do whatever, it's going to just reload that app on your behalf. So we have the same thing working. It will work on emulators. It will actually also work on your physical devices. So you can be working on 4 or 5 devices at once, change a couple of lines of CSS, and then just see what happened and whether that worked. So to show you how this works, we just run ember-cdv-s or ember-cdv-serve. You'll see it's just throwing me out some warnings, letting me know that it's making some changes to my config to make this possible. We actually tear down all of our changes as well. So once you kill the serve process, we go and undo all of the changes we made. The main change we're making is just opening up your actual allow navigation inside of Cordova to allow us to point to the running serve instance that you have. And the output you're seeing down there is just our standard Ember serve output saying that's been successful. So now I'm building the app and popping to the emulator. And we're going to put those windows side by side. I always wondered if I could get away just pretending I was doing this live. So we have our standard Ember app here, and we want to make a change to it without rebuilding anything. So what I'm going to do is just open up the standard application template and remove the welcome data and just add a header saying welcome to our app. I'm going to save that, and it's already reloaded inside the app shell for me. This will go as far as also supporting plugins as well. So when you're dealing with Cordova plugins, you're able to interact with them in this environment as well, which makes it pretty nice. You can also just go and access this running instance in Chrome or Safari if you want to do some more debugging. It's going to broadcast like a normal Ember serve instance, so it will be available on localhost 4200. So now we've done a quick tour. That is basically the CLI that we expose with ember-cordova, right? We give you the ability to do builds, to serve. I haven't shown you plugins add or remove yet. You can imagine that works exactly like Cordova plugins work, just with a couple of changes. The main change we do is that we make an assumption that we're saving the plugin on your behalf, mostly because I find as we talk to a lot of people who are using Cordova for the first time, they're not familiar that if you don't explicitly add a save flag to your plugin, it will never be added to your config, and the next person cloning the project also needs to manually add all of those plugins again and again. So we just by default make the assumption you want to save. We have prepare, which if you haven't done prepare, just imagine that's a Cordova equivalent to npm install. It's technically not and does some extra stuff, but its main purpose is to go through and look at what platforms and plugins you have installed and to pull those down for the next user so we're able to clone across projects. So another thing we need to start doing in this environment is we might need to just make some small changes to our app based on who we're building for. In a lot of cases, users of ember-cordova actually have a single app that they're reskinning for 3 or 4 different clients because it's, it might be marketingware, it might be an agency, or it might be a startup just trying a rebrand of the same app. So hooks are a good example here. It works a little bit like Cordova hooks, but you can imagine, again, we're in an Ember context here. And we just expose some hooks for you, such as before we build, once we've finished building, as well as those prepares. So if you do need to do any custom setup or teardown, that's already supported as well. We kind of went through Splash, so I'm not going to go through that in too much detail. All of these actual things we have are separate add-ons. The reason for that is so you don't need to go through and install these honking big libraries if you don't intend on using any of these single features. I'm surprised syntax highlighting isn't working here, but one of the better practices as well, and this doesn't apply just to Ember, but to any hybrid app you're building, is you don't want to take the default behavior of Cordova's Splash, which will just hide it once Cordova has finished initializing, because that doesn't actually mean our SBA app has finished initializing. They're 2 completely different things. So usually what we do is, and this is listed on the website as well if you want to read through it, is we suggest that you change your default config so that when you're doing a splash, it will not default hide when Cordova is finished initializing. And then inside of Ember, or if you're using a React or whatever we do, is at the moment that we know our app is finished loading, we then go and manually hide the splash screen. And this avoids that janky behavior you sometimes see with hybrid apps as well, where the splash screen is gone and we have a white screen for like a half second while the rest of the content clicks in. We really want to avoid that, and that's exactly how you do it. We also have a platform service. This is the only actual, what we call a service in Ember. You might have a different word for it that is within our library. And it just gives you some custom environment information. So it will tell you if you're running on iOS or Android. It will tell you if you're running in Crosswalk. It's very heavily inspired by the way Ionic did it. And the main reason you're doing this is if you do need to put in any conditionals, if you want to give a different experience to a different type of user. You should not be using any if blocks or stuff like that for conditional rendering of templates, though. In that case, I'll talk about reflow a little bit later, but you're going to just penalize yourself so much heavier later. Another thing we have here that was actually written by Aiden is ember-cordova events. So what this lets you do is go in and subscribe to what's actually happening on the device. So we're building a hybrid app. There are different things we might want to know are going on. We might want to know that the battery's about to die. We might want to know that we just lost internet. We need to back a bunch of stuff up to local storage. We might even want to know that the user's just like changing their volume because we're doing something a bit more interactive. So these are the events that we can subscribe to first class. If you've used Cordova, again, it's the same set of events. And again, inside of our Ember route, which imagine in Ember, we really care about routes, right? Routes reflect different parts of our URL and what we're rendering. As you'll see, I'm injecting the Cordova event service. And then here, just on device ready, we're console logging saying, hey, Cordova has finished initializing, we're ready to go. And as simple as that, you can put those bindings anywhere inside your app. It would be a very similar pattern even if you're not using Ember. So device ready, we always call out especially as well because we have this in big bold letters on the website. We mention it everywhere, but the question still comes up that I don't want to drop device ready if the device is already ready because then my listener will never fire and this seems like really bad code. Device ready is actually a special case that you can drop that listener at any moment in time, and if the device is already ready, that event will fire. So you can actually go through and drop device readies if you're not sure, right? You're dropping that in, say, an Ember route when Cordova is perhaps already ready. You can trust that's going to fire anyway. So please use that in every case, because otherwise you will have these weird async issues at times, and things are going to break, and you're not going to know what's wrong. Another thing here is the keyboard plugin. So I'm going to burn through these pretty quickly so I can get to more reflow-driven content. But again, you'll see here we're just interacting with the actual keyboard on the device. So you might want to make it show, you might want to make it hide, do whatever you want. Just a fun little thing that seems to hit hybrid developers as they're interacting with the keyboard for the first time, though, is that iOS and Android actually handle the keyboard a little bit differently. And what they handle differently is whether the keyboard actually resizes the browser window or not. So in one case, what you'll find is your actual height of the window just got about 300 pixels shorter. And on the other context, that did not happen at all. And a lot of the time you won't even know, right? Because it won't resize until you hit a reflow event, but once you hit it, all of a sudden all your buttons just got 30% smaller, then a user gets rid of the keyboard, now you have this like big white thing down the bottom of the screen, and you're wondering what just happened, how do I get rid of this? So for Android, your best bet is just to go and add these two little modifications to your config XML that's going to force both platforms to behave in the same way and the way you would expect. This is unfortunately just part of dealing with Cordova at times, is going through and just knowing all these little things that you need to change to have the environment that maybe you thought you had out of the box. Just it delivers something a little bit different than you think. So the next thing we start to think about is great. So we've added a keyboard, potentially we've bound to some actual events, but now we want to use it to actually interact with our app as an app, right? We still have this 200 to 300 millisecond delay. I always forget which it is because they're clicking. We want to start responding to actual touch events and swipes and spans and stuff like that. So we tend to use a library called Hammer.js for stuff like this. This example is a little dated now. I'm not even using ES6 in this. Hammer is great, and what it lets you do is start registering different events. So you might have tap, press, pan, which is swiping, and you'll notice here as well as I'm registering this first tap on, God forbid, line 460, that I'm doing taps 1. So we're actually able in Hammer as well to start distinguishing a double tap to a triple tap and trust that those are the events that will fire. So you don't need to do any manual functions, just looking at what event fired. And you'll see down the bottom here, we're actually putting in our listeners and I'm saying what it is I want to fire in those contexts. So if you're wondering how to do that, we'd suggest Hammer is probably the best answer to that. But what we just did is we went through and added touch events to everything. And now we have this fun problem where everything is firing twice, right? We tap, it happens immediately, and 200 milliseconds later, the click event is still firing. So in this context, the next thing you need to think about is just actually going and manually disabling clicks in every single context. So sometimes what you'll see people do is go and replace the touch with the click with a touch event. In my case, I usually just globally disable click and go and bind my own touch events. The main reason I'm doing that is because I'm much more interested in swipes and things like that anyway, which requires some manual work, and those can start to conflict at times. Okay, so now we're through that, let's talk about some performance stuff. pull that out because it's vibrating. So who here knows what a reflow is? Yeah, I know Aiden does. Okay, like 2. So reflow is one of the more important things to know as you're doing hybrid or even mobile web dev. It actually does affect desktop as well. It's just because people don't animate desktop as much, I think they've never noticed this before. So what reflow is at a high level is it's your browser needing to go through and figure out what am I showing where. So it's going through and figuring out how big is everything on the screen, what color is it, whatever. And it's really expensive because CSS allows us to have a rule up here that affects a node 3 levels down or 4 levels up. So we actually have to walk the entire tree several times for every single change just to figure out, well, what does something look like and where is it? You can imagine this starts to get really, really expensive, right? Especially the bigger the DOM, the more expensive this reflow event is. So before I get into that though, what causes an actual reflow event? So one of the big ones is resizing the browser window, right? Because now we have a different frame and something somewhere has to go through and figure out, well, what's going on here? Anything to do with a JavaScript computed style is going to reflow. Anytime we add or remove an element from the DOM, we've reflowed the entire DOM as well. So sometimes what you see is people thinking they're doing something good and to remove some DOM nodes they're not using, thinking that a few minutes later will be off the screen. There's every chance that you've actually cost yourself more in performance by doing that. It was better to leave it there and do one gigantic teardown later. Also changing classes, right? So just changing a class because we've changed the CSS property, we do legitimately need to walk the whole DOM up and down to figure out what's changed. So this is also, if you've ever, even on standard JavaScript development, have done an animation right across the screen and it starts to jitter or something like that. It's a good sign that's actually what's going on. So if you're interested, there's a link down the bottom. These slides will be online as well that will just take you through everything that causes reflow, and it's a really good thing to understand. If you're ever wondering how people hit these beautifully smooth animations, a lot of it has to do with just understanding this, and you can't stop it, but you can start to time when it will happen so that it doesn't matter. So if we want to avoid reflow, one nice little trick is visibility hidden. So we have a set of CSS properties that we know will not trigger reflow, even though most of them will. So again, with the example I used before, instead of deleting the node that we're not using, you might see people sometimes instead do display none, right? Let's just hide this from the DOM and it won't be there. That's actually the worst of both worlds because the thing is still there in the DOM and we've caused a reflow by changing a class anyway. If you do visibility hidden, that's a special class that will not reflow in any context. So if you need to just hide something for a couple of minutes, that's usually your best bet. Just jumping in as well, who here knows what animation frames are? Okay, a couple. So when we're playing with reflow as well, sometimes what instead you want to do is batch your work inside an animation frame. Just given it was less familiar, I might put a link up after the talk in terms of an intro to what they are. Just imagine that we have a budget within an animation frame, and the more we can time our work to happen inside of each of these frames, the more we're just getting closer to natively working how the browser is already handling events, and we're able to batch in the way we need to. Before I go into some other optimization tips as well, if you're outside of being able to use animation frames, or maybe it's a little bit too complex for your project, just start thinking about, well, what hardware accelerated or accelerated CSS properties you could be using. So I spoke about visibility hidden earlier. If you've ever noticed, like some developers get really excited about like your translate X, translate Y functions, the other reason is that they're actual animations that won't reflow as they're animating. So again, what you'll sometimes see is somebody naively do an animation across the screen, where it might be absolute or fixed position as an element, and they're just changing the coordinates all the time, which basically means each change has triggered a reflow event, every single one. If you use, say, translate X, translate Y, that's not going to happen at all, which is also why sometimes the best practice is to actually write manual accelerated CSS animations in every single case you can. They're actually not that complicated once you get on top of them as well. So some other stuff that we should think about as well is that payload size matters. So if you've never done hybrid before, this applies to web anyway, is the larger our actual JavaScript payload is, the more work we're actually putting on our JavaScript VM to figure out what's going on, how am I processing, and everything like that. There's a paper link on the next slide that if you're interested in this stuff is good to read. But imagine you get degrading performance after about 400 kilobytes, 500 kilobytes in your actual JavaScript payload in a Cordova app. At least with Ember, it might be a little bit different for other frameworks, but I'd be very, very surprised. The other big thing here is that a flat DOM really matters because we've been talking about Reflow. So Reflow is really walking up and down a tree. And obviously we don't want a ton of nodes in that tree, but if we can keep that really short and not 12 levels nested deep, then at least each of those events will be a little bit cheaper every time. So sometimes as devs, we have this really bad habit of like embedding a div in an underlined thing that's embedded in italic, that's embedded in another div that's embedded in a span. That's pretty sloppy and you're just gonna get hurt here. So try and actually actively think about what you're structuring. HTML isn't something you should just shit out because you can do it quickly. So next thing I want to talk about just really quickly is infinite scrolling, because it's another good example of people who come to hybrid and just maybe don't understand the environment they're dealing with. So when you see people approach infinite for the first time, what they do is they just have a gigantic list and figure that surely there's some browser magic, right? And only the stuff that's on the frame will render, and I can just have a list of 5,000 things and everything will be good. Everything is not good, that breaks, that becomes really slow immediately. So then you see people try different techniques, like maybe I can get some absolute positioning, I have the big list, but we'll have a viewport. That also fails. So we actually use a library called Smoke and Mirrors. It was written by a guy called Chris from Ember, who worked with us briefly. He's not with us anymore. He's at LinkedIn working on the same stuff. And Smoke and Mirrors uses an occlusion-based scroll. If you're not familiar, occlusion, if I'm not mistaken, was a technique that came from video games, whereby they're only rendering what you can see. Even though you're in a 3D world, everything behind you is not rendered at all, right? It's not real until you turn around. So in this context, what an occlusion-based scroll means is instead of having all of these nodes on the page, we only have, say, the 4 that are in viewport and 3 above, 3 below, and we're constantly just rehydrating those nodes with different pieces of data as the user is scrolling. So that lets us start to have a very, very performant scroll where we have a very limited set of stuff on the screen. So Smoke and Mirrors will automate that for you. Just to give you an example from the website, I assume you've all seen the DVMon example before. It seems to float around. But in this case, we're just jamming new data into a Smoke and Mirrors-based infinite scroll. And you'll see the thing is just not caring what's going on at all. So we spoke about memory as well, or we spoke about payload size as well, but the other thing to consider is that using too much memory is also going to hurt you in this context. When I say memory, I mean actual RAM on the device. So sometimes people think that if the RAM is there, it's good, let's just use it all, let's fill it up. You'll have the same type of bloat, right, where just because it's there, it doesn't mean you should be using it all. One of the fun things to think about in this context, so this is very much V8 specific, is that our garbage collection is something that's going to burn us here. So within garbage collection, we have 2 generations, the young generation and the old generation. If you're not familiar, by the way, garbage collection is just nodes and things that are no longer being used are finally cleaned up and that memory is actually released back. So most items will never actually make it to the old generation, right? Everything starts as a young generation item and it's just sitting there, it's still being used or it's pending cleanup. If it's still being used and it's what's called a long-running process, then it will make it to the old generation, which I think is like, I forget the actual number, it's either 85% or 95% will never make it there. And then your young generation will get cleaned up. Where this matters is we're dealing in a hybrid context where we're probably animating at the same time. And all of a sudden our garbage collector kicks in and starts to remove all of these young generation nodes, and our animation starts to stutter all over the place. So it's good to be very cognizant of how this actual memory collection process is working, because you're inevitably going to have this strange debug session where you're not doing anything and your app is still jittering, and you also can't replicate it at the same time every time. That's a good sign that this is what's going on. Okay, so I guess now is when I pause and see if there are any questions.
What would you say was one of the biggest challenges of running an app both on your web page and on Cordova, the same app?
Yeah, so it's a good question. So the biggest challenge used to be how do we handle templates, in the sense that a desktop template is very different to a mobile template. So our approach is usually that the components will be the same, and by components I might mean a nav bar or an actual card view, but the actual core, what we'd call a route template, right, like the application template or some sub things, we actually just write a custom one for desktop and for mobile. We use Flexi, which is the thing I mentioned before, which will let us detect which environment we're running in and only inject that template. But the reason for this was twofold. One is you otherwise end up writing these crazy CSS rules just to try and say, if my viewport is less than this size, do this completely different thing. But then as I was saying before, the deeper we make that DOM, the more reflow starts to hurt us. So on mobile, we like just having something very flat and specific where we can. So that was definitely the hardest bit, but now there's a tool to make that easy too. Anybody else? Great, thank you very much.